2014 question 20. The diagram below shows the setup of an experiment. Again, you're given the diagram. Which of the following may light up the light bulb? Which of the following may light up the light bulb? That means electricity, there's electricity passing through. Okay, and for those of you that don't know, this is a battery. Okay, and this is the longer end, this is the positive end, and the other one, the shorter one, would be the negative end. Okay, this just, you'll learn more about this in book 2b, redox reactions. Let's look at option 1. Heating the sodium bromide powder until molten would light up the light bulb. In other words, they're basically asking you whether it could conduct electricity or not. Okay, so we've learned of two different ways that could conduct electricity. First off is the presence of delocalized electrons, and second is with the presence of mobile ions. So here we just need to check whether any of these two criteria are met or not. We could say that. So the first one, heating a sodium bromide powder until molten. Now, of course, sodium bromide, if it's molten, as we've learned that when it's in molten state, of course, there is still presence of mobile ions. So this could still conduct electricity. So yep, the light bulb will be light up. So option 1 is correct. Adding deionized water to the sodium bromide powder. Adding deionized water. Now, adding deionized water would basically make the sodium bromide into a solution, sodium bromide solution. And because sodium bromide is an ionic compound, okay, I forgot to mention here, this is an ionic compound. And we know ionic compounds, they're able to conduct electricity in molten state or even in aqueous state. So this becomes aqueous state. And because it's an aqueous state, there's presence of mobile ions as well. So option 2 is also correct. There's mobile ions present. Now let's look at the last one, replacing the sodium bromide powder with bromine liquid. Now you may say, oh, it's liquid, but hey, be careful. It's bromine. Bromine, as we know, is a nonmetal, right? It's a nonmetal. Nonmetals, they don't conduct electricity. They don't have any delocalized electrons or mobile ions. So of course, this is not true. So option 1 and 2, the answer should be A.